Today we're going to focus on solving one-step equations when the equation starts off as a multiplication problem or a division problem. Just a quick review. Last time we met, we worked on addition and subtraction one-step equations, and we talked about what an inverse operation was. And an inverse operation is that opposite operation that would undo in an equation. So if I have an addition equation, I'm going to subtract. And if I have a subtraction equation, most of the time I'm going to have to add to undo that, to isolate our variable. So today we're going to work on isolating the variable when multiplication or division is present. We have a few different examples here just of reviewing our addition. So in this first example, actually what I would like for you to do is I'd like for you to pause your video right now, work through each of these three problems and see if you have a correct answer. When you're finished working out all three problems, hit play again, and then I will have all the work shown with the correct answer. So let's see if we're on the right track. The first two examples were pretty straightforward. So on the first one, you're subtracting 4 1/10, x equals 16 9/10. The second one, you're adding 2 9/10 to both sides, x equals 17 6/10. The last one was a little bit more tricky. You had to subtract 2/3. You also had to find a common denominator of 21. And then you would also notice when you subtract 2/3, you're not just left with x, but you're left with negative x. So when we subtract and we have negative x equals 1/21, we have to think about, well, what's the opposite of negative x? It's positive x. So then what's the opposite of 1/21? It would be negative 1/21. So like I said, today we're going to work on inverse operations for multiplication. The inverse operation for multiplication is division. Anytime we see a multiplication problem, what we can do to solve it is we can typically divide. So on this first example, we have 2 times x. To undo that, to isolate the variable, we're going to divide both sides by 2. The 2 cancels out. 2 divided by 2 is 1, so we're left with x equals 9. Always a good idea to double check your work and substitute that 9 back into the equation. Is 2 times 9 18? Yes, it is. So you have a valid answer. The second one, we have 6x equals 42, so we're going to divide both sides by 6. The 6's cancel out. We have x equals 7 because 42 divided by 6 is 7. On this next one, even though we have a fraction, we're still going to follow the same process. The 3/4 is being multiplied to the variable x, so to undo that, we're going to divide by 3/4. And as you recall, when we divide fractions, what we're really doing is we're keeping, we're changing, we're flipping. So essentially, when we're dividing by a fraction, what we really end up doing is we end up multiplying by the reciprocal. So in this case, what I'm going to do is I'm going to erase that division of 3/4, and I'm going to just go ahead and multiply both sides by 4/3. When I multiply both sides by 4/3, you'll notice that this 3 and this 3, those would both cancel out to make a 1. We're cross-simplifying. The 4's can both be divisible by 4 as well, so they both become a 1. Multiply straight across, you have 1/1, and 1 times x is simply x. And then 4/3 times 12, think of 12 as 12/1. You can always cross-simplify, so my 3 and my 12 are both divisible by 3. This becomes a 1. The 12 becomes a 4. Multiply straight across. 4 times 4 is 16. 1 times 1 is 1. Therefore, we have 16 left, and then we want to rewrite it as x equals 16. You can ask yourself, does 3/4 times 16 equal 12? Yes, it does. On this last example, I want you to try this one on your own. So go ahead and pause the video, work it out, and see how you did. On this last example, I went ahead and I multiplied by the reciprocal, because what we would do is we would divide by 2/3. And if we're dividing by 2/3, we're really multiplying by 3/2. So you can see how the 2/3 times 3/2 cancel out and makes 1, which leaves you with x. You can cross simplify your 3/2 times 8, 1. You can cross simplify the 2 and the 8 to make a 1 and 4. Multiply straight across and you get 12. So x equals 12. Now when we are solving division equations, our inverse operation here is multiplication. So when you see a division problem, we are going to think about how we can multiply so that we can solve the equation. This first one says x divided by -4. So to undo that, what we're going to do is we're going to multiply both sides by -4. The reason we're multiplying by -4 is because it was divided by -4. So you divide it by, or you multiply by whatever the variable is divided by. So since it's divided by -4, we're going to multiply by -4. -4, that's going to cancel out, leaves you with just x. And we have a positive times a negative, which is negative. And again, remember you can use your calculators when you're solving equations. So we're going to do 24 times -4, and we get x equals 96. If you want to go back and think about the work here, does -96 divided by -4 equal 24? And if you type that in on your calculator, you'll see that it definitely does. So we've done that problem right. The second one shows x divided by 2/10. So since we're dividing by 2/10, we're going to multiply both sides by 2/10. That's going to cancel out. And x equals, type it on your calculator, 26 times 2/10. You get x equals 5 2/10. Again, it's always good to double check your work. So substitute 5 2/10 in for x. 5.2 divided by 2/10 should show 26 on your calculator. It does on mine, so we're good. Sometimes division problems can be written as a fraction, like the last two that we just did, and sometimes they can be written straight across in this form. It doesn't matter which form it's in, you just have to identify where is the variable and what operation is being done to the variable. So in this case it says x divided by 4/10. So we would multiply both sides by 4/10. You should know that if you see something that's divided by 4/10 and you multiply it by the same thing, it's going to cancel out because it's an inverse operation. So now that cancels out, you're left with x, and then go ahead and type in 1 5/10 times 4/10, and you get an answer of 6/10. Double check your work. Is 6/10 divided by 4/10 1.5? It certainly is. So go ahead and pause this one. I want you to try this one on your own. When you're finished working it out on your own, I want you to hit play again, double check your work, make sure you're showing that what you do to one side of the equation, you're also doing it to the other so that you're keeping that equation balanced. Alright, so I went ahead and multiplied both sides by 1 3/10. I got an answer of x equals 2 6/10. If I substitute my answer back into where x originally was, and I do my division, I should get an answer of 2. So go ahead and type in 2 6/10 divided by 1 3/10. And yes, I do get an answer of 2. So I know that my answer is a good one. So just remember, inverse operations to addition is subtraction. Inverse to subtraction is addition. Inverse to multiplication is division. And inverse to division is multiplication. Biggest thing I'm looking for is that you, number one, have the correct answer, but number two, kind of most importantly, is that you're showing your work, you're keeping your equation balanced. What you do to one side of the equation, you also do to the other.